Welcome to this presentation about concepts for comparison in models to support decision making. My name is Ella Rubtsova, and this work has been done in collaboration with Rachel Bosche. We both present the Open University of the Netherlands. To intrigue you, we start with a question. Have you ever been in the following situation? A model has been presented, however you can't assess the model system. You want to say, so what? What is the reason of this so what situation? We would like to show the relation of this so what situation with conceptual completeness of the model, enabling a decision that this model should be implemented or that this model is not worthwhile to implement. We illustrate two findings with two distinctive modeling cases. In all modeling communities, data modeling, business process modeling, enterprise architecture modeling, there are two ways to look at model goodness. One is based on measuring with chosen sticks: size, cohesion, number of violations of rules, etc. Another is based on the intended purpose or goal of modeling. A model is good or complete if all relevant concepts of the problem domain are included into the model. We go a bit further. Any model has own goal of modeling. True. However, the model is also made to make a decision on whether the modeled system enables to achieve the goal of modeling. Taking into account that a decision is always based on comparison of concepts or dynamics of objects corresponding to concepts, we understand model goodness as conceptual completeness, allowing the needed comparison and decision. Our research questions are the following. What is an indication that a conceptual model is complete? To decide that it enables the achievement of a given goal of modeling. Where can the compared concepts come from? This book is a result of many years of modeling experience. The research method is modeling, model analysis, and generalization. We can present a lot of illustrations of our findings. However, the time is the treasure. So we have chosen two distinctive cases, illustrating two sources to achieve model completeness for decision making. The first one, concepts from different domains enable decisions. Second one, concept from different time points of the same domain enable decisions. Case 1. Marketing campaign in a bank. A bank tries to win new customers by advertising savings accounts for children in the hope that the child will continue to do business with the bank as an adult. The goal of modeling is to increase the number of customers by inviting minor customers to join. The decision to be made is if the marketing is worthwhile to implement. The concepts are derived from the process. A marketing employee sends an invitation to all its adult customers to open a children's savings account. An adult customer may ignore the invitation or submit an application for a children's savings account. Upon receipt of an application for a children's savings account, if the child is under the age of 11 years and doesn't yet have such an account, a back office employee registers the child as a minor customer who will retain that status until reaching the age of 18. So the concepts are adult customer, minor customer, invitation children's saving account, application children's saving account, and the indicators. One of these indicators is conversion rate, invitations to minor customers. We have to make a decision if the modeling is worthwhile to implement. How many customers can the bank potentially get? To answer this question, the conversion rate invitations to minor customers has to be compared with something. And we compare it with the rate minor citizens to adult citizens from the external concept demographic survey. So this case shows that concepts from different domains are compared to enable decision. Let us consider another case study. Planning and scheduling at a high school. A spreadsheet application is used to create an exam plan and a school year plan. An exam plan is created using the concepts exam, exam name, and exam code. A school year plan creates the correspondence between activities and exams using the exam code. Manual assigning of codes for a search of activities is error-prone. The high school wants to achieve consistency of plans and schedules. How can it be done? The ASIS model shows the manual coordination of exam code and activity code. The to-be model shows the restructuring. Exam becomes examination activity, becomes one of activities. This unified data structure makes it possible to replace two applications with one. The concepts to compare are found inside the system model, but at different time points, as is and to be. As is model shows only the reason of inconsistency. Comparison of concepts activity and exam in as is and activity and examination activity in to be allows to make a decision about worthwhileness of implementation of the to be system. What can we see in these two case studies? We can see that completeness of the model can be seen at the level of concepts. The presence of concepts enables mental enacting of decision scenarios needed to decide that the proposed changes enable achievement of the goal of modeling. In the first case, even the rate of minor customers is 5% of minor citizens, then the marketing process is worthwhile to implement. In the second case, if the manual coordination of activity code and exam code can be avoided, then the to-be model of planning and scheduling is worthwhile to implement. We can also see that there are two dimensions to find concepts for comparisons. Concepts can be found in the modeling domain and in the different domain, as in the case of marketing and demographic survey. Secondly, concepts can be found in the same modeling domain but at different time points, as is and to be model at a high school. The attention to concepts used for comparison may result in future in patterns of finding concepts for specific cases of decisions with respect to specific goals. For example, having many requests to model indicators and measures, we know that these models often define extensions with social concepts. Another point, the attention to compared concepts and their relations also contributes to the choice of the right level of model abstraction. Indeed, only a selection of a small set of concepts for comparison supports any decision with respect to a given goal. At the end of our presentation, we would like to thank Kirsten Burg and Martijn Bos for their graduation project work on the modeling cases. Also, thank you for your attention, and we are happy to answer your questions.